Assalamualaikum. We are from Group 2 and we'll be presenting about slope works. So this is the particulars of our group members, which consists of 4%, including me. And the first one is Mas Askiral, second one is Noor Alia Balkis, third one is Noor Alisa Azian, and the fourth one, which is me, is Noor Elena binti Norman. I'll get into the first chapter, which is the introduction to civil engineering works. Civil engineering is a broad field with many specialties, each focused on different aspects of infrastructures and construction. Today, I'll give you an overview of the main types of civil engineering works and their importance. The first one is structural engineering, which is the backbone of civil engineering. It involves designing and building structures like homes, skyscrapers, bridge towers, and dams. Advances in materials such as high-strength concrete and composites have allowed for taller and stronger structures. The second one is geotechnical engineering. It deals with the behavior of earth materials. It's crucial for projects like foundations, slopes, and tunnels. This specialty ensures that buildings are on a stable ground, slopes are safe from landslides, and tunnels are secure. Engineers in this field handle complex soil conditions to ensure stability and safety. The third one is transportation engineering, which focus on the systems that move people and goods efficiently. This includes highway, roads, railways, airports, and seaports. The aim is to design for capacity, safety, and sustainability, integrating smart technologies to improve traffic management and reduce environmental impact. The fourth one is environmental engineering, which aims to protect and improve our natural resources like water, air, and land. Projects include water treatment plants, waste management systems, and air quality control measures. This field is essential in combating climate change with innovative solutions and renewable energy projects. The next one is water resources engineering. It is about managing water resources for urban planning and agriculture. Key projects include dams, reservoir, irrigation systems, and flood control. The focus here is on sustainable water management to address water scarcity and climate change impacts. The last one is construction engineering, which involves planning, executing, and managing construction projects. This ensures projects are completed on time within the budget and to specifications. It covers urban development, infrastructure projects, and project management using digital tools like BIM to enhance efficiency and collaboration. So in our case study on slope treatment, this falls under geotechnical engineering. This field is critical for ensuring the stability and safety of slopes to prevent landslides and securing foundations.
Now we go to chapter number 2, theoretical studies slopeworks. There is three type of slopes, which is based on gradient, shape, retrain impact. For the gradient, we have four types, which is gentle slope, moderate slope, steep slope, and very steep slope. For the gentle slope, the gradient is from 0 until 5%, moderate slope 5 to 15%, steep slope 15 to 13%, and very steep slope is over 30%. For the slope types based on shapes, we have uniform slope, concave slope, and the convex slope. For the uniform slope, consistent gradient without variation, predictable in terms of water runoff and erosion. For the concave slope, the characteristic is a slope curve inward, becoming steeper toward the base. Water tend to collect at the bottom, higher potential for erosion at the base. For the convex slope, slope curve outward, becoming gentler toward the top. Water runs off more quicker from the top, lower potential for the water accumulation. For the slope types based on train impact, we have three types, which is stable slope, unstable slope, and a terrace slope. For the stable slope, minimal movement of soils and rocks, lower erosion and landslide risk. For the unstable slope, higher potential for soil and rock movement, high erosion and less landslide risk, often affected by the natural event like heavy rainfall or earthquake. For the terrace slope, is modified by the human activity for the agriculture, typically found in the hilly or mountains regions, designed to reduce erosion and the water runoff. For the component of remedial works for slope, we have micropile, soil nails, and the tie-back anchor. For the micropile, either installed vertically or at an angle, micropiles are driven deep into the ground to reach more stable layer. They support the wall by transferring loads to this deeper layer, reducing the risk of settlement and increasing resistance to lateral force. Micropile functions to transfer loads from the structure to deeper, more stable soil or rock layer, provide additional resistance against lateral and vertical movement, can be installed at the various angles to optimize support and load distribution. For the soil nail, is a passive inclusion installed into the soil to increase its stability. They are typically long, slender elements like steel bar inserted to the pre-drill holes and grounded into place. The main function for the soil nail is reinforcing the soil by increasing the shear strength, limiting deformations by providing additional support, allowing the wall to retain more soil and distributing load. For the tie-back anchor, is a reinforcement concrete tie-back wall is a type of retaining wall that uses reinforced concrete to hold back soil and provide stability. The wall is a tie-back into the soil or rock behind it with the anchor. Often used with soil nail, these anchors are drilled into the stable soil or rock behind the wall. They are tensioned to provide additional support, pulling the wall toward the anchor soil. The selection factor of remedial slope, we have geotechnical condition, slope stability analysis, load condition, hydrological factors, and the cost consideration. Next, we have construction factors, regulatory and permitting requirement, durability and maintenance. For the geotechnical condition is to understanding the soil composition, ecosystem, frictional angle, and density the crucial for the choosing the right stabilization method. For the slope stability analysis, to identifying the type of slope failure, as example, retorsion, translational, toppling, help in selecting appropriate stabilization technique. For the load condition, to weight the existing structure, traffic, and the other loads on the slope. For the hydrological factors, effective handling of surface water runoff to prevent erosion. For the cost consideration, is the available funding for the project, considering both initial construction costs and the long-term maintenance expenses. For the construction factors, the time frame required for the implementation and remedial measures. For the regulatory and permitting requirement, is the compliance with the local building codes, environment regulation, and the land use policies. For the durability and maintenance, the expected lifespan of the remedial measure, the maintenance requirement is a regular maintenance and the monitoring to ensure that continued effectiveness. There is 7 types of retaining wall, which is gravity retaining wall, cantilever retaining wall, sheet pile retaining wall, anchored retaining wall, gabion retaining wall, and creep retaining wall. Lastly, mechanical stabilized earth MSE walls. For the gravity retaining wall, the material used is concrete block, stone, bricks, or poured concrete. For the cantilever retaining wall, the material used is only reinforced concrete. For the sheet pile retaining wall, the material used is steel, vinyl, or wood sheet pile. For the anchored retaining wall, the material used is a reinforced concrete, masonry, steel anchor, cables, or roots.
Case study. So here's a little bit of project background. The project title is Cadangan Membaik Pulih Cerun Runtuh di Jalan Desa Dahlia 2, which is in Seremban, Negeri Sembilan. The contract sum is around 1.9 million. The client is by Majlis Bandaraya Seremban, and the contractor is Negeri Roadstone Sendirian Berhad. Next is the consultant, Sasa Engineering Consultant. The slope works, firstly, is to study and determine slope stability. Next is to determine the technical data required for analysis and research based on the needs and suitability of the site. And lastly is to finalize the methods of the strengthening and protection of the slope.
Construction process. Number 1. Site preparation. Clean and prepare the site including any necessary excavation. Number 2. Drill hole for soil nail and micropie. Use specialized equipment to drill hole at specific location and angles. Number 3. Install soil nails. Insert steel bar into the drill hole and grout them in place. Number 4. Install micropie. Insert steel casing or reinforcement into the drill hole, then grout them to create the micropie. Number 5. Construct arch wall. Build the reinforcement concrete wall, incorporating tieback anchor if necessary. Component of slope. Number 1, slope face. Number 2, slope 2. Number 3, slope chest, back slope, berm, slope inclination knob face, soil layer, drainage system, vegetation, reinforcement element, surface protection, and underlaying bedrock. But not at all them used for repair slope. It depends on what method you use and site condition.
Is the challenges of this case study. Firstly is the environmental factors, weather conditions, heavy rainfall or extreme weather impacting repairing works. Next is erosion control, managing ongoing erosion during and after repairs. Next is geotechnical issues, which is unstable soil conditions, difficulties in assessing and stabilizing verifying soil types. Next is water table variations, which is fluctuating groundwater levels affecting slope stability. Next, logistical challenges, which is access to the site, difficulty in transporting materials and equipment to the slope area, limited space, restricted working area for heavy machinery and workers. Lastly is the community impact, which is disruption to residents, minimizing inconvenience to local residents during repairing works, and communication, keeping the community informed about the project timeline and progress. The environmental impact. First, erosion and sedimentation. Construction activities can disturb the natural vegetation and soil structure, leading to accelerated erosion. Sediment runoff can degrade water quality in nearby streams. Next is habitat loss and fragmentation. Sloping works can lead to habitat loss and fragmentation if not properly managed, disrupting wildlife corridors. Third, water quality issues, which is improperly managed slopes can contribute to sedimentation in water bodies, affecting aquatic life and water quality. And lastly is visual and noise pollution. Construction activities associated with sloping can cause temporary visual and noise pollution, impacting local communities and wildlife.
In conclusion, repairing and maintaining the slope at Desa Dahlia is crucial for safety and stability. This report highlights the main issues and solutions, emphasizing the need for careful planning and ongoing efforts to keep the slope stable. The Seremban City Council is dedicated to reducing risk and improving safety through thorough inspections and advanced engineering. Regular inspections, comprehensive emergency plans, and sustainable repair methods are vital. These steps are essential for managing and changing challenges of slope stability. By following these measures, the Seremban City Council can significantly enhance the community's safety and development, ensuring a secure and thriving environment for all residents.